One-step equations. When we solve an equation, we've got to undo what has happened. We do the inverse operation, or we do the opposite of what is there. So when we're looking at addition or plus, the opposite to addition is subtraction. So when we see a plus, we take away. So here we've got x plus 9 equals 17. You could probably do this in your head by saying, what do we add to 9 to get 17? Okay, so we need another 8. So 8 plus 9 is 17. But we need to see the mathematical process because not all of them can be solved in our head. So we need to have a system of answering these that is the same all the time. Okay, so let's start. We've got plus 9. We say, what's the opposite to plus 9? We take away 9. So we go minus 9, and what we do to one side, we do to the other. So 9 minus 9 crosses out because that becomes 0. So we just bring the x down here. We rewrite what's left. So we've got x equals 17 take away 9 is 8. We can then check by substituting or putting it back in the question as we did earlier. 8 plus 9 equals 17. Okay, so now we have p minus 12 equals 30. The opposite of minusing 12 is plus 12. Plus 12 to each side. Minus 12 plus 12 crosses out because it becomes 0. We write the p equals 30 plus 9 is 42. Let's check that out by substituting back in. If we make the p 42, 42 take away 12 equals 30. Okay, so nice and simple. These ones are involving a times because 3x means 3 times x when it's joined together. So we say to ourselves, what's the opposite of multiplication? It's divide. And instead of writing a divide sign, we can do a fraction bar because that means the same. So we've got 3x equals 18, so it's 3 times x equals 18. What's the opposite of timesing by 3? That's divide. So we're just going to divide each side by 3. So the 3's cross out because 3 goes into 3 once, 3 goes into 3 once. We're left with an x on this side. 18 divided by 3 is 6. Let's check that out. 3 times 6 is 18. Okay, 7x equals 28. So 7 times something equals 28. And once again, I could say to myself, okay, 7 lots of 4 is 28. But we're practicing how to set it out properly, so make sure you do your working. So we're going to divide both sides by 7. By putting them over 7, remembering a fraction is the same as divide. So the 7's cross out, and we're left with an x. 28 divided by 7 is 4. Let's check it out by substituting in. 4 times 7 gives us 28. Nice and easy again. Okay, remembering I just said that the over sign or fraction sign is the same as the divide. So this means x divided by 2 equals 5. The opposite to divide is times. So we're going to go 2 times this side and 2 times this side. If I have 2 times x, it gives us 2x over 2, and the x's just cross out. So by doing the opposite, what we're trying to do is get rid of what's on the side that our pronumeral is. It's just cancelling it out. So that's why we're doing it. So x equals 2 times 5 is 10. Let's try that out. 10 over 2, or 10 divided by 2 is 5. B. P divided by 8 equals 6, so we're going to times by 8. The 8's cross out and leave us with a P. 6 times 8 is 48. Check by substitution. X equals 142 into the equation x over 9 equals 17 to see if the answer is correct. So this is what I've been doing verbally, checking each of my equations to make sure they're in fact correct. So we'll put 142 where we see x. So we've got 142 and both sides should equal. Does 109 go into 142 17 times? Let's have a look. 9 into 14 goes once. Remainder 5. 9 into 52. How many times does that go? Well, 5 nines are 45. How many more makes 52? 7 over 9. that should equal 17. Does that equal 17? It doesn't. So if I did that question and I came up with the answer 142, when I went to check it, I'd go, oh, my answer's wrong. Let's have another turn at it and see if we can get it correct. Okay, so therefore x equals 142 is not a solution. It's very important when you're in exam to do this little therefore sign if they're asking you a question, because just getting to the end isn't saying, yes, I know what you're talking about. So the little therefore sign and a statement is a really good thing to do in mathematics to ensure the marker knows what you're doing. Okay, so that's one-step equations. Have a go at that, and then we can move on to harder two-step equations.